Okay, so now let's make or finish making our table. So I chose y values, -1, 0, and 1. Now I'm going to plug them back in here. So I'm going to plug in -1 first. So 1/3 to the -1 power plus 3 equals, and you can go ahead and type this in if you need to, but 1/3 to the -1 power is going to be 3, plus 3 is 6. So 6 goes here. Now I'm going to plug in 0 for the y. So 1/3 to the 0 power plus 3. Well, 0 power going to be 1, plus 3 will be 4. And then I plug 1 in for the y, so 1/3 to the first power plus 3. And that's going to be 3 1/3. Okay, so now I'm going to graph. So okay, so those are my points. Now we need to figure out what our asymptote is, so I can draw that in. Now once it's in exponential form here, remember that the asymptote is going to be whatever comes after the exponent stuff. So in this case, it will be x equals 3. Now, those of you that didn't need to go through this process, you could just type this into your calculator and it worked out for you. Notice that your asymptote is the number that would number for x that would make this come out to be 0, because you can't have a 0 or a negative number in a log. And so if you plug 3 in there, 3 minus 3 would be 0. Or you can look at it as the asymptote will be opposite of what this looks like in the parentheses with x. So this looks like -3, so the opposite of it is +3. So that means that my asymptote is at x equals +3, so you need to draw in your dashed line that represents your vertical asymptote. And so then your curve will be something like this. Don't let that cross the asymptote though, because it never crosses the asymptote. Okay, so now domain. So domain is your x values, so that's why you use your asymptote information in the domain. So I use x, and then I use that 3. Then you ask yourself, am I using the x values on the right of the asymptote or on the left of the asymptote? And we are using the x values on the right, so that is x is greater than 3. Those are the x values we're using. And then remember the range, it's going on forever in both directions, so that means, or I'm sorry, yeah, the range is going to be all real numbers. Okay? So that's how you figure out what your asymptote is. In this case, if you just look at this equation, the original log equation, it'll be whatever's opposite of what's inside the parentheses in the log. If you change it to exponential form, once you change it to exponential form, it will be whatever comes after the exponent stuff, which in this case was the 3. So if it's an exponential form, you don't need to change the sign. All right. Let's try one more before the exit slip. So we're going to graph this function. Now, you cannot start changing this into exponential form until you isolate this log information. So you cannot start turning this into exponential form until you get this log stuff by itself. So that means I need to get rid of this 2. So I'm going to add 2. So then I get y plus 2 equals log base 4 of x plus 1. Okay. Now that this log is isolated, now I can change it to exponential form. So log base 4 means that 4 is your base. These guys split up, so your exponent is this whole thing, y plus 2. And that's going to equal the log stuff, which is x plus 1. So just like we use the definition just like normal. This is your base. These guys split up, so this is your exponent. The whole thing, y plus 2 is your exponent. And then this stuff in parentheses in the log is what it equals. Now I need to get x by itself. So that's minus 1 here. So I get 4 raised to the y plus 2 power. Now that minus 1 is not in the exponent, and that equals x. So that's my exponential form. Now I'm going to change up my y values that I pick a little bit here, because I'm going to make it so that this would be 0 is one of my choices. So if I plug in -2 for y, that would make a 0 exponent. So I'll do -2, -1, 0 maybe. Okay. So if I plug in -2 up here, so that'd be 4 to the -2 plus 2 power minus 1. Well, -2 plus 2 is 0. 4 to the 0 power is 1, and 1 minus 1 is 0. Now I'm going to plug in -1 for the y. So 4 raised to the power 1 plus 2, then minus 1. So -1 plus 2 is 1. 4 to the first power is 4. Minus 1 gives me 3. And then if I plug in 0 for the y here, so I do 4 raised to the 0 plus 2 minus 1. So 0 plus 2 is 2, 4 squared is 16, minus 1 is 15. So then I have 15, 0. Now that'll be off my graph a little bit, but that's okay. I can estimate where that's going to be. So graph 0, -2, 3, -1, and then 15. So this is 10, 11, 12, 13, 14, 15, probably about right there. Okay. Now looking here, look at your exponential form, which is right here. So then what is your asymptote going to be? Well, hopefully you're thinking that your asymptote should be x equals -1, because -1 is what is after the exponent stuff if you look at the exponential form. If you're just looking at the log equation, it's whatever's in the parentheses of the log, but you do the opposite of it. So there are two different ways you can do that. So then I draw in my dashed asymptote at x equals -1. Draw in my curve, so it's going to increase pretty quickly here. Domain, range. Remember, domain is your x values, so since the asymptote says x equals -1, you're going to use those numbers. I'm using the x values to the right of that, so that'll be x is greater than -1. And then your range now for log functions are all real numbers, because we're eventually going to use all the y values. Okay? All right, so now go ahead and pause this and see if you can state the asymptote for this function. So pause it for about 2 minutes. This should not take you very long to find this answer. Okay? So it should either, if you just left it like this, then remember to get the asymptote, it's whatever in the parenthesis with the log, but it's opposite of what it looks like. So that would be x equals -3. That's your asymptote. Now, if you change this to exponential form, you would have added 2. So you would have gotten y plus 2 equals log base 2 of x plus 3. Then you would have changed this to exponential form, so 2 raised to the y plus 2 equals x plus 3. And then you would have subtracted the 3 over and gotten this. Which again, this would be your asymptote number, which is exactly what I had here. But if you realize when it's in the log form that your vertical asymptote is whatever value you plug in for x that would make this 0, which ends up being opposite of what this is, then that's your answer. Okay? All right, so for the rest of the time, you should work on the 7.4 worksheet. It's all about graphing. You can check your answer with my answer key to make sure that you're doing this correctly.